So, emerging technology in continuation. In the last class we could not finish because obviously as and when the new things are coming up, we are also getting stuck into that to explain more and more. Right now, in continuation of the previous class, let us look into that. This is under dairy and food process and products technology, and this is the 11th lecture, right? And we are talking about the emerging technology in continuation, right? So, if we look into this, then we see that the previous one was like this. That high voltage electric pulse, right? Or if we remember that we talked about in the previous class ultrasonication, then heat and pressure, all these three together in combination we had said as one of the technology, emerging technology which is coming up, right. Then we say that high voltage electric pulse, which we said in the previous class. Now, let us also explain a little, so that we understand what the process is. High voltage electric shocks, right, and that is called electroporation, is given to inactivate the vegetative bacterial cells. Vegetative. Now, the previous class we also said one more thing, that was the spore former, right. So, those vegetative cells which become more resistant, then they form spore former. It is not that all organisms can do the spores. There are very selective organisms which can form the spores, and they become the resistant too, right. So, in this method of electric pulse giving the high voltage shock, and that spoils the vegetative bacteria or vegetative cells as well as yeast and mold. Vegetative means which can grow under given favorable condition rapidly, right, normal growth. So, in that case they are called vegetative cells, right, while bacterial spores are much more tolerant. So, for spore former, which we have seen in the previous one, there even the spore formers were affected, but in this the spore formers are not. So, because they are tolerant to the high voltage shock or high voltage pulse given, right. Then what it does, high voltage breaches the structure. So, breaches means, if we understand by the term breach, English term, that is that you are dividing or you are breaking something. So, right. So, it is breaking the structure of the cell membrane, which is controlling many of the vegetative cells homeostatic mechanism. Homeostatic means the condition where it can grow easily. So, that homeostatic condition is being broken, and the and maintenance of the cytoplasm, that is also cytoplasmic pH, that is also getting hampered. So, this pH gradient across the membrane and the osmotic balance of the cell, all these are being hampered by the by the electric pulse which is applied. So, the breach, that is the structural break of the cell membrane, that occurs, and because of that the vegetative cells are not able to grow, right, because that is also affecting the homeostatic mechanism of the cell, as well the cytoplasmic pH and pH gradient across the membrane and osmotic balance, all these are getting affected, right. The major disadvantage in this process is that the treatment time requirement or number of pulse requirement is very high, right. So, that is the primary, that treatment time as well as the number of pulses. You remember we had shown earlier that pulses means we said like this. So, this is an electric pulse. If that is how these cycles of pulses, if they are very high, right, then that becomes one disadvantage, right, as well as the time, because the more the pulses number required, more will be the time required. So, that is the basic disadvantage, and synergism with other preservative factors may improve efficacy. So, that means simultaneously if we can apply some chemicals along with this, then we can get synergistic effect along with this high shock or high voltage, right. For example, we said niacin and other bacteriocins that potentiates the lethal effects of the electroporation, right. So, this potential can be improved if we take the help of simultaneously some others along with this. So, again it is a combination. So, high intensity high light pulses, which I also said. So, in that high intensity laser and non cohesive and non coherent light pulses are used to deactivate or this can act as a microcidal effect. That means it is killing the microorganism, right. Often new practical approaches to the decontamination approaches to the food and packaging material surfaces, right. This offers new practical approach, this high intensity pulse to decontaminate the surface of the food. So, this killing effect not self sufficient, but killing effects may sometimes result from the partial heating because of the light which is being given. So, that may increase the time, they increase the temperature, that may have some partial killing effect. So, process like physical removal of microorganism from surface, that is ablation, and ultraviolet irradiation are required to form the basis of the technique, and this requires detailed research. So, it is still under infant or not on infant, under research program, but this also has one thing that in many of the cases where handling of the food products become difficult, right. So, during handling they may incorporate some contamination, and this contamination on the surface that can be easily minimized by these high light pulses, right, high intensity light pulses. So, that is a very good thing which can come up, right. Then high intensity magnetic fields. So, if you also incorporate high intensity magnetic fields like oscillating magnetic fields, right. So, where this oscillation inactivates the microorganisms on the packaging material. So, you have already packed the material. Now, you want to minimize the or remove the organisms or kill the organisms. So, this high intensity magnetic field or oscillating magnetic field can come up as one of the rescuer of your system, right. Then the mechanism is believed to be that magnetic energy couples into dipolar molecules and may change membrane fluidity and interfere with the fluxes across the cell membrane. Right? Bacterial spores are not affected. In all the cases, whatever we have discussed till now, you see the spore formers, because spores are very what should I say, it is very resistant, tolerant to normal conditions, by which the vegetative cells are destroyed easily. So, here also that mechanism is more fruitful for the vegetative cells, but may not be so for the spore formers. And this efficacy of the treatment have not exceeded about 100-fold reductions in the number of vegetative bacteria. Right? Subsequently, you will see that in the death cycle, right, there are many such things which come up. Death cycle, where it is termed in terms of how many number of log cycles it is being reduced, whether it is 12D, 6D, 10D, 8D, that dictates that what is the number of cycles reduction. That is, originally the number of organisms present could be 10 to the power 12. Now, after your reduction, if you do 12D, then it should come to 1. Right? So, in that case, it is like that. So that this microbial, that limited applications are because of that. It is spore formers are not inactivated, and not more than 100-fold, that is 100 times, that is 10 to the 2, it is not getting destroyed. So, examples are Streptococcus thermophilus inoculated into milk, Saccharomyces cerevisiae in orange juices, or mold spores in bread. If they are looked into under this kind of thing, then it is sent not more than 10 to the power 2 or 100 folds, the reductions are being managed to obtain. Then we come to the microbial safety. If aim is to inactivate microorganisms in foods, if that is the aim, to inactivate the microorganisms in food, then there must be some basis for judging it, right? And the efficacy required to deliver a sufficiently microbiologically safe product, so that you can depend that yes, this process has efficacy and has been proved its efficacy, and it can be applicable in terms of microorganism or microbiologically it is safe, right. So, how normally thermal processing is traditionally based on the particular inactivation kinetics, and there typically it is said, just before I was referring to that, for the sterilization of the high water activity and low acid foods, it is said that 12D concept of the targeting spores of proteolytic strains of Clostridium botulinum. Clostridium botulinum is one organism which is considered to be highly spore forming and very heat resistant. So, if that is destroyed, then it can be said that yes, the food material is away from the, or is safe from the microbial point of view. Similarly, pasteurization, in that it could be 6D or 8D concept that may be applied, Now, this D concept, perhaps this is also not within our this course curricula. So, we may not be able to go into in detail, because that is the death kinetics of the organism. So, if everything has to be told in the class, then till the course will not be covered. So, I advise you that you please also look into the death kinetics of the food material of the microorganisms, right, where this D value, Z value, these F value, these will come up, and you can easily pick up what is being said, that what is 12D or 6D, right. So, these conclude that suitable, that are often this, that the process 6D or 8D processes are often concluded to be suitable targets for the destruction of the pathogenic organisms, because pathogens are not that much heat resistant or that much resistant. So, in that case, when pathogens are getting destroyed, then we can say that the product is microbiology or pathogenically it is safe to consume, right. So, that 6D, 8D, 12D, these concepts are coming. So, you please also consult that death microbiology of the material. I hope we have finished a little early in this, but here then we can say that new technology which are emerging, there are many more emerging technologies are there. So, it is not that all the time we can utilize them or all the time we can bring them into. As we said, 1-2 cases we have said that it is still under the lab scale, lot of some more researches are required, and also the destruction of or elimination of the organisms are not to the extent as it is required. So, in that case, more and more thorough investigation has to be done, and then only we can say yes, that is done, right. But since we have some more time, then let us also look into that what are the difficulties in introducing the new or this technology which we are coming, which we are calling to be emerging, right. This emerging means they are coming, right. They are coming, but they have not come up. So, we have to keep in mind not only the microbial contamination. Yes, microbiology or microbial contamination is one major, because either it spoils the food material, or it is making the consumer affected with the maybe pathogen or some other organism. So, if that is removed, yes, a little we are assured of the safety of consuming the food, but the primary concern is the efficacy of the new technology which you are bringing in. So, new technology when you are bringing in, that time definitely you should not be only considering the microbiological status, but also others. Like the other day we had said the quality, that overall quality concept, overall quality aspect, right, both in terms, if it happens that to do that microbiologically, yes, like high pressure, right. So, when you are giving high pressure technology, that time you also have to keep in mind that it is not only the organisms which you are considering, but also the appearance, the color, the shape, the size, the texture, then if it is viscous material, the viscosity, or if it is not, then viscosity should not be increased. All these aspects, if the viscosity become increased, again that word we use, pumpable or not, right. If it is low viscous, then pump required, that the cost on pump or the energy on pump requirement will be less. So, it is more acceptable. But if the process changes the viscosity, so that it becomes highly viscous from whatever it was, then definitely the manufacturer who will be implementing this new technology will think, no, may not be that this technology at the moment can be implemented, right. So, to consider a new technology, lot many other aspects other than microbiology is required to be kept in mind, right. And in that case, we should be very much what should I say? It is we should be very much judging the process, judging the technology in terms of its efficacy, right. So, efficacy of course in terms of organisms, but also in all other quality aspects that we have to keep in mind, and also the process cost, which is very fundamental, because high pressure technology, to create that high pressure you have to have system and this is normally hydrostatic pressure, and in that case high pressure development will be a major obstacle for the implementation, right. So, if your instrumental cost is very high, to bring that instrument maybe several lakhs or crores rupees you have to incur, then that cost will come onto the product. So, the product which was otherwise with conventional mechanism, which was available, maybe say for comparison 10 rupees a piece or a pouch, it was available. If that pouch now under high pressure, if it is to be costing around 50, 60, 100 rupees, obviously the consumer they will take it otherwise, and they would keep their mind and face from the this technology, right. So, when we are approaching, when we are adhering to the new and newly developed technologies, then we should also consider the cost primarily, because technologically it may be very good, but the cost wise, if that is not comparative, if that is not at par with the already available technology, then the purpose is defeated, right. This we should keep in mind, and we should also look into the quality aspects all put together. It is not when you are judging technique or technology, that times it is not a single parameter on which you will decide. Technologically it may be proved that yes, the purpose may be served, right, for which the technology has come up. Yes, it is serving the purpose, but it is again with respect to both microbial or non-microbial status. But again the price also, then again it becomes that if the price is also comparable, but the implementation that may need lot of peripheral others, like it may not be the friendly to the ecology or environment. So, in that case, keeping everything okay, then the developed technology, because of the non-environmental friendly, because it being non-environmental friendly, may not be acceptable and may not get the light, so that people will accept or implement it. So, when new technologies we are concerning, we are definitely considering the effect, we are definitely considering the effect on microorganism, we are also considering the quality aspect of the material as well. One more, that if there be any nutritional disorder, nutritional destruction of the process by which you are killing organism, by which you are doing. So, nutritional quality that went down, then obviously you will not be able to sustain with the new technology. So, nutritional balance, nutritional quality should also not get hampered with the technology you are bringing into. I am not against high pressure. It is not that. I am not saying that high pressure technology is bad, or the other one, high electrostatic field or high magnetic field, whatever we have discussed, or combination. Now, we have also seen that technologically the combination system may be applied, right. Combination scheme may be thought of in such a way that all put together synergism may occur. But again, that this is not one aspect, but other aspects of the contribution towards the maintenance of the nutritional value, towards the cost incurred, or it also can be that the initial cost, may be very, very high, but operating cost is very, very low, right. For example, that air conditioning, right. If the air conditioning is made with the conventional air refrigeration system, then the operating cost becomes very, very small. So, there the initial cost could be high, but since the operating cost is very high, very low, then people will go for it. But if someone is bringing something where the initial cost is very low, but operating cost is very high, then that becomes a headache to the implementer. So, if he or they will think that why should this operating cost, because operating cost, initial cost, you may get people or who are the entrepreneur, they may get bank support or support from other agencies, but the same may not be true with when the operating cost is high, because the operating cost has to come from the manufacturer or processor. So, they will think twice, right. So, I am not saying one factor, it is that only that initial investment or operating cost. While you are considering, you have to consider all in totality, such that you can say yes, our system is foolproof and proof from all the sides. So, emerging technologies which will come up, they have to compete from all corners with the already existing systems. Okay? So, let us stop it today here. The time is over. So, again that please look into the thermal death kinetics of the microbes from some other sources. Okay? Thank you.